My name is Hadley Westover, and I'm really excited to talk today about threat modeling and how threat modeling can be an excellent tool to add in helping to secure our systems. So to get started, I would like to see, just by a raise of hands, who has used threat modeling as a tool in their work or things that they've done. Okay? Quite a few hands. That's great. So, yeah, threat modeling definitely is not some, miracle process that if you do it, everything is great and you have no problems whatsoever. It's definitely nothing magical, and I'm not going to try to tout it as such, but it is a very effective tool and one that is great to add to our overall approach and how we secure our systems. So first, a little bit about me. So I actually live up in Weston, Idaho, just across the border, so close to Logan, Utah is where I work. I went to school at Utah State to get my undergrad, and then got my master's degree from Western Governors in cybersecurity. So the last 7 years, I've worked at the Space Dynamics Laboratory in Logan, Utah, and they are a university-affiliated research center associated with Utah State University. So SDL is the government comes to us with problems that they need solved within core competencies that we can provide and give to them. So I started there as a software test engineer and did that for a couple of years. And then as I had graduated with my master's, I then transitioned over as a cyber engineer. In doing that, I helped to develop our threat modeling process within our company. So the process of how we would incorporate threat modeling, how we would use it, what would work for our systems and our existing processes, and help to establish that. And then I regularly do teach at the company the threat modeling class to raise awareness throughout the company of threat modeling and how they can use that. So as I'm going through this presentation, happy to answer questions all along. So if you have a question, just call it out in case I don't see hands, and I'll definitely try to answer it. So I'm going to start with a fictitious story, and it's a cautionary tale about a company called Innovate Co. So this company, they were really smart, lots of smart people, very brilliant, and they had created this groundbreaking new product. It's a smart home device that promises to just revolutionize people's daily lives. There's a lot of hype about it. Their engineers are rock stars and getting this together. Their marketing team's on fire, and their investors are ecstatic about this. The mantra here at Innovate Co. was speed to market. They wanted to be the first, the fastest, and the most disruptive. So they built their product at lightning speed. They got features added, code written, the hardware acquired and created, and they met all their deadlines with just heroic effort. Now, the security part of it, well, that's something they thought, okay, yeah, we'll get to that later. We don't have time right now, but we'll work and add things later with that. We did a basic security review, and so that's good for now. We've got to keep this moving and get it launched. So the product did launch, and it launched with rave reviews, and sales soared. They were just really on top of the world. The champagne corks popped, and everyone was just celebrating their huge success. And then the phone rang. And it wasn't a customer service call. It wasn't someone just wanting to write a review about the product, but it was a security researcher, a white hat hacker who had found something pretty alarming. They found this critical vulnerability that wasn't just a minor bug, but it was a gaping hole in their architectural design. So it could allow the attacker to compromise the device, compromise the entire network where that device resided, and cause just devastating harm. So this caused, huge panic within the company. And that fix-it-later mentality had really come to bite them, because this wasn't a simple patch that they could push out and have everything good, but it was a fundamental flaw in their architecture.
Jeez.
So the engineering team, who had been celebrating just days before, were now working around the clock, fueled by caffeine and sheer terror, just trying to get everything fixed and updated to remove this huge vulnerability. Costs were staggering. There was just lots of plummeting stock prices. People were losing trust. They were returning their devices, and InnovateCo really went from being a market leader to a cautionary tale almost overnight. So this company, they learned the hard way the true cost of late-stage vulnerability discovery. They learned that baking in security later is like trying to add the foundation to a skyscraper after it's already been built. It's expensive, disruptive, and often too late. So their mistake was simple. If they would have added threat modeling early on, that would have definitely helped. And then additional pen testing and security reviews all throughout their development cycle, they could have avoided this problem and had everything turn out great. So like I said, this is just a hypothetical company, but it really does reflect a lot of the challenges that many of the organizations that we work with face. So what is threat modeling? So threat modeling is a way to really get proactive in security design to make sure that we can identify, understand, and mitigate problems and vulnerabilities early before it's been designed and built, when it's a lot easier to make changes. It really, when we can identify those early on with that shift left security, it can dramatically reduce costs and timelines and help to make that more secure system. So there's 6 main steps to threat modeling. The first one is to define your scope and the objectives. So really answering the question, what are we working on? The second thing is to decompose the system. And that is really answering the question, how does it work? Third, identifying the threats. So what can go wrong in the system? Fourth, what threats matter most, or determine and prioritize the risk, which answers the question, which threats matter most. Then 5, identify and implement countermeasures and mitigations. So what are we going to do about it? And then 6, validate and iterate. So did we do a good enough job? Where do we need to, go through this again or work on it more? So we'll go through each of these 6 steps, talk about what's involved with them, and how to do them. So the first one, defining the scope. So this is really, identifying what are we going to be threat modeling? What system or new feature or any component of the system or entire infrastructure, what is it that needs to get done? And what are the boundaries for it? What are those interactions that will take place in it internally and externally, all the assets, and yeah, what is our timeline and resources to do this? When do we need to have this done? So kind of as an example, based on this Innovate Co. So, defining their scope, they identify, okay, yeah, this will be our smart home device to start with, and then our supporting server infrastructure that it will be connecting to and transmitting across. We know that customers are going to interact through our app and our web browser, and that it's going to reside on the customer's network, and so it will be going through there to get data to us. So, and then there'd be a list of other things that would need to be added to this, but that would be the start of where you're defining the scope would take place. So then the second thing is, now that you have the scope, you know what you're going to be doing, you then decompose the system, break it down. Data flow diagrams are extremely helpful in doing this and helping to show, okay, what are the internal components and processes within the system? What are the external entities it's connecting to? What interactions are taking place between each of these? What data will be flowing between there? Where is data being stored? And yeah, so what do we need to do to protect those? Where is trust being changed? And where are those trust boundaries throughout the system? And those trust boundaries is where we'll then identify those are areas where an attacker can try to exploit a vulnerability or gain access to a system. And so later on, we'll see how that's where we look to determine what vulnerabilities exist. So it's good when we're diagramming our system to start with the context diagram that really shows that big picture. And then depending on the size of the system, we can start creating that level 1, level 2, level 3 diagrams down, showing different pieces and in more detail. So definitely no point in going too detailed, but just that enough detail that you can really understand the system and know what is going on. So a couple quick examples. So just an example of a context diagram. It's a little small, so a little hard to see, but just really shows how the data is flowing in and out with this hypothetical smart home device through the customer to their servers and databases, and those trust boundaries of where, okay, we need to make sure we're protecting the system. So context, and then just an example of a level 1 diagram that then is looking at the smart home device within it, its different hardware and sensors and components and what it interacts and talks to kind of show those details and the data that's going across and what additional trust boundaries are there. So once you have identified that scope, you've decomposed the system, created all these diagrams and understanding of the entire thing, your threat modeling, you can move on to the third one of identifying the threats. And so when we're identifying where are those potential threats, where are those things that an attacker may want to do at each of our trust boundaries, it's helpful to use a framework or methodology to just help make sure that we're being comprehensive, that we're picking up all of those different things. So here's a list of a few of them: Stride, Dread, Pasta, Trike, Vast, MITRE ATT&CK. All of these are really great. And it just helps when we're kind of brainstorming ideas as a team and figuring out, okay, what, based on the current architecture, what could exist. In my experience, I have mostly used Stride, so that's the one I'm going to break down and talk about more and show examples of, but these other ones are good and have their uses as well. So Stride. Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So we'll talk about each of these. So the first one's spoofing. So this is when an attacker is able to impersonate as a trusted source. They're able to say they're, a different user or different account to be able to trick into getting access or things that they shouldn't. So if we think back with our Innovate Co. company, this could be maybe there was default admin credentials that aren't changed and that they're able to, use those to impersonate the admin to get access to a device, just as an example, many others. Next one, tampering. So this is when an attacker is able to modify either the data or the code or any other aspect of the device to do or get what they want. So example of this one, of an attacker puts malicious software maybe on this smart home device where then the company's servers, it can validate, oh, this device is one of my own. I trust it, so I'll just accept whatever data comes from it, and could be a way to get malicious data there onto the remote servers. Repudiation. This is where an attacker can deny whether that they did it. So their actions can be hidden, and there's nothing we can do to prove that they did it. So logging is definitely the big thing with this. So the example here is if logs aren't being generated and sent so that they can be analyzed and seen, then if an attacker tries something, they can deny that they did do that. Then information disclosure. This is really getting access to data or information that an attacker shouldn't be able to access. So just for the example, an attacker uses a SQL injection to get into one of the databases for the deployed smart home devices, and even, for all customers. Then denial of service. Next one, this is just that the attacker is able to disrupt the functions of the system. So, and there's an example there that could happen in our hypothetical. And then the last one, elevation of privilege. So this is where an attacker is able to raise their permissions to a higher level in the system. So, maybe an attacker with a normal user account, but yet it's the API to the web interface isn't using good means of authentication, and so they're able to access pages and resources with the API reserved for admins, because they're able to kind of use spoofing along with elevation of privilege to get that elevated privilege. So a really useful thing then with Stride and all of these different ways we look at is we determine where we need to apply each of the Stride categories. So processes, those are the internal pieces of the system. Those are where we have full control of. We can influence the design or the way things work. So with those, we look at every part of Stride. Within the data flows, so that's where data's moving or data in transit happens. So there isn't spoofing there because, you have your two devices that are talking to each other, and, each device needs to authenticate and say who they are, but we're not necessarily looking at the data itself that goes through that flow isn't what we're looking at for the account. So that's why for the data flows and the data stores, we're just looking at tampering of that data, changing that data, information disclosure of that data getting out, or denial of service, preventing that connection from happening. And then with external entities, those are things that are customers' machines or another company's machines, like we don't have control over, we can't influence, but we can check to make sure that they are who they say they are, and we can log and know everything that they've done on our system. But other than that, we don't have the full control to influence those other parts of Stride. So definitely a very nice table to use to make sure when we're doing threat modeling that we're applying Stride and looking at it depending on what the component is we're currently looking at. So that moves to step 4. So we've identified all of these threats. We've gone through Stride and identified, okay, here's these possible vulnerabilities. We've then gone and verified whether those vulnerabilities do actually exist in our design and in our system and could cause problems. And so then when we've done all that, we determine, okay, what are the risks of each of these vulnerabilities and which one is the highest risks and which one do we need to prioritize and it could cause real problems. And then after that, we move into step 5 of applying mitigations for those vulnerabilities that we found, for those threats. And so it's good when we're applying mitigations that we're not trying to just homegrown, write our own things, write our own mitigations, but that we're really using the standards and frameworks that are out there that talk about the best ways to do them. Everyone, can do something that they think can make their own tool or apply their own mitigation that they think is secure, but it definitely using those resources, those things that have already been tested and had gone through the rigor, that's what we want to do when we apply our mitigations. So there really are 3 main types of mitigations that can be applied. So the first is a design change, changing the design of our system, the architecture that would then just remove that vulnerability and make it inherently secure. There's adding different security controls on top of it to protect it, or then operational procedures of, make sure that users or administrators do these things to keep it safe. And so when we're looking at mitigations, we want to prioritize in this order, that if we can just influence the design to add that security just built into it, that's really where it's the best. And we're not relying on people or other things to just protect us, because those don't have near the strength, and we know people always mess up. So for each of the Stride, I'm just going to quickly go through and just kind of show, what a mitigation kind of looks like for that. So we had our example of the attacker using the admin credentials. So the mitigation could just be that those default admin credentials have to be changed when you're setting up your device. Excuse me. Okay, so next, tampering. Got a frog in my throat. Okay, so tampering, the attacker is able to manipulate our device. So mitigation would be, excuse me. So checking, having code signatures, signed code to make sure that the device isn't able to have malware put on it and not be able to infect our systems. Repudiation, so same thing that with the sending logs, make sure that audit logs are periodically sent so we can look at it, we can assess what has been done on the device, we can see maybe what attackers are trying to do and what we can do to prevent it, and other analysis of things going on. Information disclosure, so making sure that we're doing proper input validation, sanitizing all SQL calls before they're made, and just using good software coding practices. Then for the denial of service, there's a lot of different things could do. Just an example, load balancer to try to scale and move things around so that that denial of service doesn't happen with our server and that the devices are able to connect and talk. Then elevation of privilege, making sure to use cryptographically secure session tokens to restrict admin access, make sure that if it is an admin that logs in, that session token is cryptographically secure, can't be spoofed, or the attacker isn't able to guess it or anything. So next we go into our 6th step of validating and iterating on our design, on what we have done. So, we've applied the mitigations. We've looked and verified that those mitigations we did will resolve the vulnerabilities, that they'll fix the things that are wrong with our system, and that our system is more secure. We ask ourselves, did we do a good enough job? Is there anywhere we need to look at a little bit deeper? Do we still have things that are still going to cause us problems? And then as the system evolves, as new features are added, things are updated, then decide, when are those points when we will threat model again, look at it again as the design's changing, and see what new things have been introduced and make sure that we're keeping it secured. Sure. So those are the main steps of threat modeling. Those are how threat modeling can assist our organization and what we need to do in it. And so, there's a lot of convincing our organizations to devote the time and resources to do threat modeling. And here are some of the things, the points that you can show and say, hey, this is what threat modeling can do. Yes, it is early on in our system design or later in the system design, wherever. It may take some time and some money, but it will bring cost savings because we're identifying things as early as possible. Those problems, it's really making us proactive and not reactive to security findings and vulnerabilities. It can really help with the compliance side of things. It can help us make sure that we design the system to meet these compliance standards and that we're not trying to scramble at the end to meet those. It does give cross-team collaboration. Security engineers, they need to be working closely with the software developers, the systems engineers, the program managers in order for threat modeling to be successful. So it really does give that early collaboration and going back and forth and a lot more information sharing instead of being siloed off in individual groups. And then, threat modeling is a great way to identify and prioritize the risks, make sure we understand what, if this gets completed and shipped out, what's the risk that we could have, because we've already identified what's in the system, what we were able to fix and what we weren't able to fix because of different XYZ. So who should be involved with threat modeling? So like I said, it is a collaborative effort with many different people. So your security engineers are involved, take part in it, developers, architects, your testing, Q&A, having them involved early, they can help with the threat modeling of, these are things that you can test for and look for, or what we would be doing later on. So you can be looking at it earlier in the design, and really those product owners making sure they're on board and willing to have you do the threat modeling and perform those steps. Yeah. So what tools can we use when we do threat modeling? There are a lot of great tools out there, things that can be used. Shouldn't overestimate the power of whiteboards, of getting into a room with your team and just whiteboarding, drawing things up, talking it through, like giving that collaboration and discussion is really important. But other tools, your basic drawing diagrams for all your data flow, things that your data flows you're making. So Draw.io, Visio, others, there's a whole bunch of others. And then threat modeling specific tools. Microsoft, they've got their free threat modeling tool that you can use that can do a lot of this. OWASP has their Threat Dragon tool that works really good. And then Stride GPT is available out on GitHub, where they've put together where you will connect an LLM such as ChatGPT to it, and then this tool has optimized prompts and queries that you can use to use LLMs to help with doing your different assessments. You can upload the diagrams into the system. You can put all sorts of information about the system that you have, all the documentation, and then it can help you determine, okay, yeah, these are the possible stride vulnerabilities that may exist and speed up the time and development. So a cool tool to go and look at. So, yeah, got through that a little quicker than I thought, but threat modeling is really a great tool to add. Definitely some things that more organizations should be including, should be looking at early in their system and involving their security people early into the design to make sure that security isn't an afterthought, that it is built in, and this really will create a system that is a fortress, secure from the attackers, and oftentimes it's just the better design overall, and that the system will work better itself, having those security features built in. So with that, open it up. What questions do people have? Things that I can answer. Okay. Sure. I can definitely, share my slides. So I'll ask and see if there's a way that I can get those shared. Otherwise, you definitely can email me and I can send them to you as well. Be happy to, share them with anyone. Yeah. So for everyone, the question he was asking is at my company, is it really the product owners that we reach out to get involved in doing this process? And yes, that's what it's been, is we've gone to our customers, which is these different government organizations, and have mentioned, yes, we can do this. And like they have come to us with their unique systems that aren't your typical IT systems, really embedded systems, cover a lot of custom hardware, firmware, software. And so those are what they've come with. Some of them we've developed, some they've had others developed, and then they've asked us to do this threat model of the system and to look at it and see where it was secure. So in our case, it's been us kind of reaching out that, hey, we can do this for you. And then also some of them just coming to us saying, hey, we want you to check the system we're designing, make sure it's being designed securely. And we say, hey, yes, we can do that. And this is the process that we're going to use to do that, to make sure that we do a good job. All right. That's a great question. So everyone heard it. The question was, do we use certain tools or things on different groups and attacker groups to make sure that we're doing it based on that? We haven't really used like a tool on that. We do, when we do our threat modeling, we do try to identify, okay, what are the types of attackers that are most likely to attack the system. We like to then put within our report, okay, these are the goals that they would want to accomplish, and create that attacker profile or pull it from other places and paint that picture before we then get into the details, because that does really help influence the threat model of, okay, these are the type of things we should be looking for, because, the people that are the organizations looking for our system are these, advanced persistent threats or whatever. And so we need to make sure that we're applying the rigor towards what attacks or vulnerabilities that they could discover, that we're putting that same rigor to identify them early.
maybe I saw F. It's plus that side. Listening to the tenant that it's just this is my more fair.
Yeah. So the question was, getting the security shift left can be really difficult. And so, what are the things we can do to help put that into our company? And that's definitely something I've struggled with in this company I work for. So, like I said, I was one of the ones that helped just develop this threat modeling. So they had a company come out and give us some training because there was one upper management that thought, oh, this sounds like it can be really good. And he came from a cybersecurity, so he had us do it. And then we got trained. We started looking at it and, oh, yeah, this can be great. But then it was like, oh, well, yeah, we can start applying it to this system and this system and this system. And we definitely got a lot from management of like, oh, no, we're good. We already have it. And so it's definitely been over the last 4 or 5 years has been really slow, but we've been persistent and just keep reaching out to different product owners, saying, oh, we could do this, or we can do this scope down, just this little piece. Let us look at this little piece and do it. And slowly there's been like, okay, yeah, we've got a little bit of money here. Have you go do that. And then they've seen, oh, yeah, that actually did a lot. And it really actually accomplished. And we put that out there to our upper management of, oh, look what we did and what we were able to do. And then they give that to our customers, and their customers are like, oh, yeah, we like that. And it slowly has built so that now we're actually getting in to the point where we're getting more of the work and they're seeing the value of it. So I don't have this is the perfect way to do it, but it is a slog and it takes time and just being persistent of letting them know that, yeah, this actually will save you time and money, and try to let us do a maybe experiment on just a small scale, and then you can see how it can help throughout the enterprise. Other questions?
Okay. Great. All right.
Yeah, so the question, I'll go back just to bring them up, was on the different frameworks for recognizing, identifying threats. Are there pros and cons to each one? What are their strengths? I know I haven't used a lot of the other ones to know all the pros and cons with it. I know that the way like Dread and Pasta, they do look at it a little bit different. So it can be really helpful to just look at multiple of them, and they can help pick up things you've missed. I don't know if one's necessarily better for certain applications than other. I've used Stride and MITRE ATT&CK, and I've liked both of those a lot because I feel Stride is used quite a bit in the industry. Has a lot and I feel like it's fairly comprehensive. And then MITRE ATT&CK just gets really good into specifics, depending on what the attacker's goals are, and then it gives a lot of great mitigations that you need to apply to it. So I don't have a great answer of this is when you'd use this one versus this is when you'd use that. It's a lot of experimenting and just seeing what works best for you. Other questions? Okay, if there aren't any other questions, I'm happy to have anyone come up and talk to me, talk more about this and anything. Also, I'll show them my email once again. Feel free to email me. I'll be happy to reach out, share my slides, have further discussions. And thank you all for coming.
Should be.